I hope you guys went through YouTube videos of this neural networks theory. Today, we'll discuss or we'll see how to prepare any data set with a artificial neural networks. So the first step, what I am doing is I'm importing essential libraries. So coming to the essential libraries, I am importing NumPy, which is used to perform numerical computation. Then next I'm importing pandas to read the data which is present in any data set, either it might be CSV file, Excel file, or HTML file. Then next, TensorFlow. So previously, whenever you want to work upon any classification project with a machine learning, there we took help of scikit-learn, that is a scalar. Similarly, whenever you want to work upon with the deep learning, at the time we have to take help of TensorFlow. So scikit-learn previously, now we are going to take TensorFlow. Okay, now I'm running this code. Sorry, prior to this, what I will suggest you is go to runtime. In the change runtime type, you can keep it to T4 GPU. Okay, as by default for me, it is set it up to this. Whenever you're doing project now, you can click on this. Then next, I am checking the version of TensorFlow, which version I'm using. So 2.15. Okay. Then next, as you know already, if you want to take up any data set from Kaggle, we have to upload that kaggle.json file here. Now I'm doing that. So I'm uploading kaggle.json file. As you can see, we added kaggle.json file. After this, as we have to set up a file for kaggle.json, as you know, these commands, same commands, I copy pasted from previous code block only. As if we don't do this also, it won't impact anything. Okay, perfect. The next thing is after uploading kaggle.json file, now we kept it in a local folder. You can see in this folder, you can see kaggle.json file. Okay, for confirmation purpose, whatever the kaggle.json file available or not, you can check from here. Once you find it, what you can do is we have to download the data set. Okay, we have to take a data set from Kaggle. How to take it? As it is a URL for this one, Chan modeling data set. So you can read the description regarding this data set and you can know about the data set from here. So while coming to this data set, what I am doing is we are having three dots here. I'm clicking here. We'll be having copy API command like that. I copied that API path here. After taking this API path, I added this exclamation mark. It means we are saying it to download this data set. Okay. Once it is downloaded, this data will be available in the form of zip file. You can see it is in the form of zip file. So to process the data, we should have this data in the form of some unzipped format. So for that purpose, I am unzipping above folder. Okay. So whenever you want to unzip, you can add this command space and you can copy the zip path. This path, copy path option you will be having. You can paste that line here so that it will look like that. Now it will be unzipped and you can see the CSV file will be available here. Chan modeling.csv. Okay. So now the next what I am doing is, however we did previously, we have to read the data present in this file. So how many color rows we are having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 records, 14 columns we are having in the data set. So we are loading the data and we are looking at the data set. So it is the data set which is related to banking. Based on the personal details of the person, finally we have to say whether the person needs to be stay in a bank or he should exit based on all his parameters. So exited is an output. Exited means left the bank. Okay. So 1 means left the bank, 0 means not left the bank. So now However, we did previously. Now here also we have to divide the data in the form of inputs and outputs. Okay, so now if you look at this data set, you can see row number. It's not at all required to understand, like to predict this outcome. As it is a unique number, it won't impact anything. That's why I am not going to consider it as an input. Coming to the customer ID, as it is also a unique ID to each and every person, it is also won't contribute anything for an output. And surname. Based on surname, we can't say whether the person stay in a bank or he will exit the bank. So these three parameters don't impact anything in an output. These parameters won't contribute in an output at any point. That's why I want to remove those columns. I don't want to consider those three columns as an input. So for that purpose, I am saying x equals to data set dot index location is the function, as you know this. So we are performing slicing. So in the first place, we said colon. It means it is corresponding to row slicing. It means we are taking all the records. Coming to the next column slicing, in the columns from third column, means from credit score column to the last column. -1 is nothing but last column. Colon -1 I am saying. So colon -1 means, as you know, the ending index always excluded. It means this accepted column won't be considered under this. Okay, so that's what happened here. No, except this accepted column from credit score to estimated salary will be our inputs. Okay, now coming to the output, only last column is our output, accepted column is our output. That's what I'm saying here. Now randomly, like I want to see the output present in X. So you can see it is starting with 619 and it is ending with 101, this value, estimated salary value. This is the available values. So if you look at Y also, you'll see the output, like the complete column, accepted column in an output. Now, whenever you want to apply any machine learning algorithm or deep learning algorithm, so we should have a data in the form of numerical format. So if you look at this data, in this data set, we'll be having geography of a person. It means country of the person. It is in the form of text. Coming to the gender, it is also in the form of text. So we should not have a data in the form of text. So previously, to clean this data, we used a label encoder and one hot encoder. Here also we are doing same thing. So by taking help of label encoder, we are applying this label encoder technique on all the rows corresponding to second column. It means country column. Y means like a country column will contain only two values in this example. France, Spain, Germany. No, it is having more than one values. So as we can use one hot encoder, but in this example, label encoding the gender column. Oh, here he is encoding gender column first. So Y means like let's suppose if you look at this data now, yeah. So it is an X. So 0th index means this credit score. First index means France. Second index means female. So as coming to the gender, we'll be having only two categories. That's why he is going to apply label encoder from sklearn. And he is performing this fit transform. He is applying fit transform method. And once you apply this technique, if you observe the output, in the previous values, wherever the female is there, that will be come up with 0. Wherever the male category is there, that will be come up with a 1. Okay, that will happen whenever you apply label encoder. The next will be having country column. So as I told you, if you have only two categories at the time, we can go with a label encoder. Whereas if we have more than two categories, we have to go through one hot encoding technique. By considering that, here for to convert the countries, we are using one hot encoding. So for that, as we know, we have to take help of column transformer. We have to take one hot encoder, and in the column transformer method, we have to pass this one hot encoder object. And we have to pass the data through all the attributes. Okay, that's why we are saying reminder equals to pass through. And we are applying this one hot encoder on the data. Now we can see this country column. It will be converted in the form of numerical values, and this column will be added at the first in the data set. Okay, that's about one hot encoder. Now, if you look at the data, we don't have any string values or text values. Everything in the form of numeric and passion only. Now, we can split the data into training and testing. This step also very common. How we did in a machine learning. In the same way, we are splitting the data. After splitting the data in the form of training and test set, so we have to keep all the values in a same scale. Remember, it's a very, very important step coming to the deep learning process. Whereas coming to the machine learning projects, if you don't do this also, it won't impact much. But coming to any deep learning project, you should perform scaling. Okay. On the complete training data and test data, we are applying this technique. Now, we are building an ANN model. So, if you look at this X, so now what I'll do is I'll say X dot shape. As it is an attribute, oh, got it. It might be deleted, I think. X, yeah, capital X, okay. You can see like totally we'll be having 12 columns in the data set after pre-processing doing everything, and we'll be having 10,000 customers records in the data set. Okay, now we scale the data. After scaling the data, we have to build the model. Okay, so now we are building the model. So whenever you want to build a Keras, like a deep learning model with the ANN, we have to take help of TensorFlow for sure. So we imported TensorFlow initially as a TF. Then next, under the TensorFlow, we'll be having Keras framework. So every model will be implemented on Keras framework only. So to work upon deep learning projects, we'll be having two technologies. One is we can use a PyTorch framework, like a PyTorch, which is a Facebook's product. Another one is a TensorFlow, which is Google's product. So most widely, most of the people will use this one, like TensorFlow, as it is a low coding one compared to PyTorch. Okay, so now Keras, from the Keras library, we are taking help of models. So whenever you want to implement any deep learning model, either it is a ANN model or CNN model, we have to take help of sequential function. With this help of sequential method, we can build any model. Or to flow the data from input to output, we need this sequential. Or else you can remember, like if you want to construct any model, we have to take help of sequential, which is present in the models, and models is present in Keras. We are taking Keras from TensorFlow. Okay, that's what we are doing here. So the meaning of this thing is we are initializing the model. Whenever you want to initialize the model means you have to import sequential method. Once you initialize the model, we have to construct the model next. So constructing the model means we have to add more and more layers. So here initially I'm adding first input layer. So how we can add an input layers? So ANN means this sequential. For this sequential, we are adding the models. So whenever you want to import the model, we have to import it from models. Whenever you want to add the layers, we have to import the layers. We have to import any, like if you want to add any layer, we have to import it from layers. So as it is a CNN project, directly we can add a dense layer. So coming to the convolutional layer, convolutional neural networks, there will be having more and more layers. Like we'll be having max pooling layer like that, hidden layers like that. We can add more and more layers. Whereas coming to here, we can add a dense layer. So here I'm adding hidden layer, first hidden layer. Now you can see in units means number of inputs I'm going to consider. So here I'm specifying 6. How I'm specifying 6 means totally will be having 12 inputs, right? So I am compressing all the 12 inputs into half. Okay, that's what we are doing here. And the activation function is relu. Remember this layer, whatever we are adding, it is the next layer of input. It means it will be said as a hidden layer. Remember, in a deep learning, in the hidden layers, most of the cases are like every time we'll use ReLU activation function. That's why I'm using activation functions. If you remember the architecture of ANN, how it would be, like if you look at the structure, right? I'll plot it here. Okay. Where is the sketch? Yeah. Yeah, I noted. So let's suppose if we consider like ANN architecture, first we'll pass the input. Let's suppose you'll pass an input. Like totally, let assume like a scenario like we'll be having four inputs. So these are inputs. So let's suppose input 1 will goes here, x1, input 2 goes here, x2, and input 3 goes here, x3, and input 4 goes here. So it's an input layer. Then next, coming to the hidden layer, we will reduce the number of layers. So coming to these, so as it is a completely fully like a connected layers, dense means it will connect all the nodes. Okay. So now it will go like this. So similarly, this will also connect with all the things. So based on these probabilities, so final outcome comes from this two. And here, let's suppose if you have an input output layer. Okay, so this two will be connected with this. So finally, based on this, you'll get some probability. Now, what we'll do is we'll get a weighted average. So let's suppose if it is x1 and if it is x2, if it is x3, it is x4. Now we'll be having priorities w1, w2, w3, w4, so on. Like that, based on these priorities, whether this will be activated or not, whether this value should be passed to the next layer or not. And based on these weights also, this should be proceed to next layers or not. That will be based on complete probability. So to pass this value from this to this, whether it should go to this or not, it will be depends on activation function. There we are taking ReLU activation function, rectifier linear unit function. It will be like this. Okay. So if the probability like if it is have value more than some threshold, it will pass to the next layer. Otherwise, it won't. Okay, that is the meaning of this ReLU activation function. Okay, so now after doing this, oh, yeah, I'll go to the next steps. The next we are adding another hidden layer. After this, with the same 6 units, we are adding another hidden layer. It means, so in this example, we took 4, right? Coming to the 4, here, like he took 12. Coming to the 12, next he's compressing it to 6. Then also he's adding 6 more here. Okay, like that he's proceeding. Then next, he is proceeding to the next sigmoid. Like a sigmoid is an activation function which will be used for one output. So coming to here, the final output would be, I'll come up here. Yeah. So on that example, he took one more hidden layer. Like this, he took. And coming to this will be connected with this two. And this will be connected with this two. And from these two, finally, we are getting output. So coming to this output, here we use it sigmoid activation function. So sigmoid means, as you know, you learned it while discussing logistic regression. So it's a completely probability curve. So if the probability is below 0.5, it means category 0. It means person don't exit the bank. 0 means. If the category like probability value above 0.5, if this activation function gives probability more than 0.5, it will be said as that person will exit the bank. Okay, like that you can understand. Remember, in a hidden layers, most of the times we'll use ReLU activation function. Whereas in the output layer, we'll use sigmoid activation function. Remember that. Okay. So that thing you should remember at any time while working with a. I'm discarding this. Clear all ranks. Perfect. So now here we are taking help of sigmoid activation function. So after taking sigmoid activation function, now we have to train the model. So far we build the model, we build the architecture. So whatever the architecture we built, we have to compile that model. Coming to the any ANN or CNN project, we have to compile the model. So from ANN, we are taking help of compile method. ANN means here TensorFlow only. From that, we are taking help of compile method. Optimizer means it's a weight optimization technique. Like like if you see the gradient descent or stochastic gradient descent, like that, if you want to optimize the cost, means error, we have to specify some activation functions. Like optimizers, we'll be having optimizers like Adagrad stochastic descent, SGD stochastic descent, gradient descent, RMS prop. Like that, you can use any optimizer. The best one is Adam. That's why I'm using Adam here. Loss means to check the error or to check the cost, which activation function you have to take. So if we have two categories at the time, we have to take binary cross entropy. If we have more than two categories at the time, we have to take help of categorical cross entropy function. And coming to the metrics, here I'm considering accuracy as a metrics. Okay, like to check the model performance, I'm considering accuracy as a criteria. Now, after compiling the model, it means it will understand to optimize the weights, to give the priority to each and every input. I have to take Adam as an optimizer, and I have to check error by taking help of binary cross entropy function. And then next, I want to consider accuracy as a performance metric. Algorithm will understand this stuff from this line. Then next, we have to train the model. Training the model means fitting only. So here also we are using fit method. Coming to the fit method, we have to pass X train and Y train. Based on this model will learn and optimize the parameters. Batch size. For in each and every iteration, I have to consider 32 records. Epochs 100. Like this, by iterating through each and every sample batch of records, model needs to be optimized. Change the priorities. Okay. Changing the priorities means if you went through the like a theory video of ANN, you'll understand. So initially it will give some priority to the inputs. With that priorities, if it is not getting proper outcome means it will change the priorities. It will give like importance in a different way. Like that, the model will adjust the weights based on Adam and finally it tries to give very good accuracy. So we are training the model. Like that, we are training the model 100 times. Epochs equals to 100 means 100 times. It is like you are preparing for some exam. You are checking your performance 100 times. Like you are taking self-exam. On your own, you are keeping an exam to you and you are checking your performance. Like that, we are doing here. So to run this complete model, it will take some time. So after that, after training the model, we have to check model performance. Yeah, as you know, like before checking the model performance, like you'll get it accuracy here. Accuracy like test accuracy like something 82, 86 something. So here we can see the accuracy. Okay. After that, what I'll do is like I'm like here, this is the task to you. So if the person geography is France, his credit score is 600 and he belongs to male category and his age should be 40 years. Like that, he given all the parameters. His tenure is 3 years with the bank and balance is 6 lakhs or $60,000. Number of products he purchased two. Does the like does this customer have a credit card? Yes. Is this customer active member? Yes. Estimated salary. He's getting salary like $50,000. And so based on this parameter, we have our model should say whether this customer stay in a bank or he would exit. We have to predict that stuff. That's our task. So for that, so whatever the parameters he has given, I am specifying those parameters here. So we'll be having three countries there: France, Germany, Spain. In an alphabetical order, France will come first. That's why I kept one